Hello everyone, and welcome to our new live webcast, Security and Protection for Machine Learning. Thank you for joining this new masterclass. With each episode, we provide new highlights, technical tips, and success stories that will leave you inspired and ready to get your protection, licensing, and security techniques another step closer to perfection. At WIBU-SYSTEMS, we empower software publishers and intelligent device manufacturers with cutting-edge technologies, new business models, and tailor-made consultant training. Let us help you upgrade, optimize, and automate your entire license lifecycle management so you can focus on monetizing your business at a higher level. My name is Daniela Previtali, Global Marketing Director at WIBU-SYSTEMS, and I'm delighted to have you here with us today. We are joined by Axel Engelmann, Architect Protection Technologies from the headquarters of WIBU-SYSTEMS, and Andreas Schad, Professor of IT Security at University of Applied Sciences in Offenburg. Machine learning is reliable, provided the AI algorithm that generates the trained model is sound and has not been tampered with. The IP you need to protect includes the training dataset, the training setup, and the resulting trained model. With CodeMeter, you can encrypt the model to safeguard it against unauthorized use, copying, or espionage in both online and offline scenarios. Additionally, CodeMeter can encrypt and sign data to add an extra layer of security on top of anonymization and pseudonymization. Some housekeeping we need to take care of before we start. For everyone who's joining us today, I want to remind you that we will be reserving some time at the end of the session for Q&A, and I'd like to invite you to submit any question you have in the live chat box. This session is being recorded, and a link to the replay will be posted directly to you in the next couple of days. And don't forget, stay with us throughout the live session for your chance to win 4 hours of free CodeMeter consultation from the most brilliant minds at our company. At the end of the webinar, a new tab in your browser with 3 simple quiz questions will show up. You should submit one choice for each multiple answer question. We will draw the winner from among those who reply correctly and notify them at the time of the replay announcement. Please also note that the winner is excluded from all subsequent prize draws of 2022. Without further ado, I'll pass things over to Axel. The floor is yours.
Hello, this is Axel speaking from WIBU-SYSTEMS. And I'm looking forward to give you a sneak peek in our latest protection technologies for machine learning models. And at first, I would give you an outline for our presentation or webinar. So my colleague, the ML expert Andreas Schad, will first tell you something about the basics of the machine learning lifecycle for programs. Also tell us a little bit about current techniques. After that, I want to share you some insights about the CodeMeter basics, and afterwards we will look into the protection of machine learning models. So Andreas, stage is yours.
Okay, thank you very much, Axel. So we got about half an hour, and in that half hour I'll do my best to actually give you an introduction to machine learning. And then basically I'll try to convince you that it actually pays off to consider IT security as part of the machine learning lifecycle, and specifically consider security-related question as early as possible in your machine learning lifecycle. So not only am I trying to give you a quick overview of what machine learning is, but also what the machine learning lifecycle is, as well as what the assets are you're trying to protect, and against which kind of attacks you're trying to protect these assets. Now, obviously, it's not possible within 30-odd minutes to give you really a complete overview of what machine learning is, so we are just taking a really high-level perspective. And in the widest sense, my personal interpretation is that machine learning is some specific field of artificial intelligence. And to be a little bit more precise, from an engineering point of view, is a set of techniques and tooling that I basically think now complement our traditional software development lifecycle. So why do we do it? Why do companies actually do machine learning? Well, The traditional way of developing software is just imperative programming. So you program your algorithms, maybe for industrial machinery, and sometimes you got programs and sets of algorithms which contain a lot of rules. So a lot of decisions you need to make. So you can think of thousands of if-then-else statements that try to capture the complexity of the real world. And whenever you encounter computer programs that are very dependent on or even hard code rule sets, then these might actually be perfect candidates for a longer term replacement by trained models, by models which were trained with techniques of machine learning. And a very good example of that is Google. So Google offers email services, and traditionally Google also offers a spam filter to filter incoming spam or filter email and decide whether it's spam or not. And traditionally that actually was a program with many different rules. So basically rules that allowed the program to decide whether an incoming email is spam or not spam. And actually a couple of years ago, Google decided to replace this spam filter. Well, actually it didn't replace the spam filter. It replaced the implementation of the spam filter. So moving from a traditional procedural approach to a machine learning based approach. Why? Because, well, Google had a lot of data, or has a lot of data, and has a lot of examples of what classifies, or historic examples of what classifies as spam email. And on the basis of that data, Google trained a machine learning model, and this machine learning model replaced the procedural program, basically. Sometimes people refer to this as software 2.0. And this is something we actually observe now in industry in general. So sometimes actually it makes sense to really replace your software or improve your software by machine learning based models, and sometimes that can actually really reduce your maintenance costs as well. So why did machine learning pick up over the last, well, decade roughly? First of all, we saw the emergence of cloud platforms, and with cloud platforms came two things. One is actually the ability to record or to produce enormous amounts of data, and we need that data actually for training our machine learning models. And secondly, cloud platforms now offer us huge resources of CPU power, not only CPU power, but actually GPU power. And we need this computational power for training purposes, because sometimes the data sets we use for training and the training itself, the training process itself, that just simply takes a lot of CPU power. And actually, we only need that CPU power once for the training process. So then it naturally makes sense to actually use computational frameworks that are offered by big cloud platform vendors such as Google, for example, or Amazon Web Services or Microsoft. And lastly, over the last years, we have seen the skill set increasing. So as part of our standard computer science curriculum, students are now educated with machine learning skills. Sometimes we even see very specific master programs, for example, for machine learning or data analytics. And these students now actually hit the market as a workforce, and the available skill set available to companies for machine learning purposes is increasing, which just again acts as another stimulus for machine learning overall in industry. But it has only been recently that people started to think about security as part of the machine learning lifecycle. So when and why should I take care of security as part of my machine learning lifecycle? And on the right-hand side, you actually see a small publication we wrote with WIBU-SYSTEMS, which was sort of a relatively accessible analysis of what the machine learning lifecycle is. and at which stages of the machine learning lifecycle we may observe certain types of attacks and what we can do about those attacks. And I would highly recommend or encourage you to actually have a look at this resource. So you should see it on WIBU-SYSTEMS web pages. So again, 30 minutes, impossible to give you a complete overview of machine learning, but just two basic examples for two very, very common types of machine learning. The one is you got a lot of data, the little X's you see on the first graph on the right-hand top corner. And on basis of the distribution, you can actually train a model, and the result of that model is actually a curve, or in this case, a straight line. And that means that on basis of historical data, so the little X's which are there already, you can now make forecasts. So you then basically train the model, and the result will be an n-dimensional, well, in this case, a two-dimensional line, but it can be just any n-dimensional structure. And then you can actually start questions. So given the trained model and given another X, what will be the possible Y? And with relatively high confidence, it will tell you what the Y value in that case would be. A second classical part of machine learning is that of classification. So here in that little graph, or that little example, you see lots of little cats and little mice. And this is our historical data, lots of pictures of cats and lots of pictures of mice. And then we train a so-called classifier, a model, to distinguish what a cat is and what a mouse is. Well, yeah, they have 4 feet, they got a little tail and a little nose, but nevertheless, there seem to be some differences. And the differences are exactly where we see the dotted line. The dotted line is the decision boundary, and anything on the left-hand side will actually be classified as a cat. Anything on the right-hand side will be classified as a mouse. And with that, we will be able to submit a new picture to our trained model. And if that picture just so happens to be a mouse, the model will actually say with relatively high confidence, it is a mouse, or it is a cat, or basically it's not a mouse or a cat. So what could be real-world examples? Well, real-world examples of the first type of model. The first type of model are so-called regression models. You use these type of models when you actually want to make predictions. Predictions about the future based on already known data. In financial forecasting, so for example, in maintenance prediction, so when do you need to take care of a certain component in your machinery, or for example, in network analysis, so you have a lot of past network data, and that will actually allow you to make predictions about future network load. And you could, for example, use classification models to help you with spam filtering. That's what we saw is happening at Google for general image recognition, as we see in self-driving cars these days, or for example in networks in intrusion detection. So you have got a lot of historical network traffic, and you know as part of your historical traffic what was legitimate traffic and which was sort of traffic subject to malware or to possible intrusions. And then you can observe, actually you can more or less do that in real time, your current network traffic, and you will be able to distinguish whether it is benign traffic or actually it is malicious traffic and somebody's trying to intrude into your network. So to give you a little bit of more haptic example, on the left-hand side you basically see data. So that data, what could that be? That could be emails, that could be recorded network traffic, that could be images of cats and mice. And then you take that data and you basically make it subject to the training process. And the training process is basically, in many cases, it's Python glue code. And that Python code basically will, with the help of specific algorithms, generate a so-called trained model. And this is a little bit like at my university. I would ask my students, what do you see or what can you observe in line 54? In line 54, you could actually see save model. And this is actually the result. So anything that's happening above line 54, that's the training process. So data is taken, raw data is taken, and some training process is executed over that data. And as a result, you have got a model which sort of captures the characteristics of the data. So you can make predictions or you can make classifications. And that's basically what my colleague Axel will show you later. This trained model, the so-called H5 file, is something that you may want to try and protect. And now we're going to reason about why and against whom we actually need to protect our assets. So the machine learning lifecycle consists of two phases. The first phase, as we already discussed, is the so-called training phase. You need to collect your raw data, then you actually need to pre-process your data. Sometimes people also call it feature engineering. And when the data, the raw data has been processed, then you can actually make it subject to the machine learning process, and the output is a trained model. For example, that classifier to detect whether a picture contains a mouse image or a cat image. And the second part of the life cycle is the so-called inference phase. So you've trained your model, and your trained model is now deployed maybe on a cloud platform, maybe it's just within your company network. Actually, a lot of us actually have got a deployed model on your mobile phone. Yeah, for example, the major mobile phone vendors, they use machine learning based approaches for improving the qualities of photos that are taken. So actually, most of you do have a deployed model on your mobile device. And you give it input, again, a picture of a cat or a mouse, and output will be a prediction. So with 99% certainty, this is a mouse. Or with roughly 60% certainty, this will be a cat. And this is the so-called prediction. If we now try to be a little bit more specific, then the machine learning lifecycle consists of three main stages. So first one is the data collection phase. That's when you take your raw data. That could, for example, be data from your IoT devices that you record consistently. And this raw data, as I said before, needs to be pre-processed, and that's actually the hardest part of them all. This is actually which is still very manual labor intensive, luckily. So we actually need trained data scientists to mangle the data into a format which is fit enough to be subject to training. The training itself is actually not too difficult. And once the training has been done on the result will be a model, and somebody will then pose a query once the model has been deployed and obtain a result. And that could be in your cloud platform. So you make maybe an example of a query could just be a REST call to a cloud and an answer, or maybe on your mobile phone, when you try to take a picture. This can take different forms. To add to that, we've got two more artifacts. One is a set of algorithms. So these are the algorithms that are used for training. So for example, a random forest or a Bayesian classifier. And the second is configuration data, and that's basically the secret recipe. This is like the Coca-Cola recipe, which distinguishes the quality of your training process and your model from your competition. So inside the configuration, it will just make the fine-tuning of your training process. So lots of little numbers and digits, which basically improve the accuracy of your training process. And as a result, in this relatively simplistic model, we already got 6 different assets which may be subject to security requirements. So your raw data, who's taking care of securing access to your raw data? Where does the raw data come from? Your model, how do you protect your model against being copied? The query, how do you protect your environment from random queries? So enable only authorized or licensed people to make query and basically obtain results. How do you protect your configuration data? As I said, this is probably the most important data next to the trained model, as it really distinguishes your model from that of the competition. And so you need to ask yourself, how do you protect that model? And things actually become even more complex because the naive assumption is that only one person is responsible for everything. So one person is actually responsible for the raw data, the same person is responsible for training, deploying the model, making queries, and that's actually not true. So the data owner on the left-hand side can be completely different legal entity to those who are involved in the actual training process. And the person who is actually owning the model, legally owning the model, can be completely different to the engineers who have been commissioned with doing the training. That can be two different companies. And the training process itself or the model could be hosted on different cloud platforms or the same cloud platform. And again, that is not necessarily the cloud operator, not necessarily the same legal entity as, for example, the machine learning engineers. And the customer on the very right-hand side, who is actually asking questions, making queries, asking questions, does not necessarily have to be the same person as the data owner. So can be completely different people. So we saw already in that simplistic picture that we need to look at a couple of different dimensions. So one is, at which step in the machine learning process are we? Are we in the data collection phase? Are we in the training phase? Are we in the operational model phase? Then we need to consider which data or assets are we talking about? Raw data, configuration data and algorithms, the trained model, the query, results of the query. And lastly, we need to consider who should have access, maybe under which licensing conditions, to which of these assets. So you see it already becomes relatively complex, and it actually pays off to think about these questions before you start with your machine learning project, and not as a post-mortem activity, basically. And to make it worse, unfortunately, many different types of attacks have already been reported, not only in the scientific literature, but in the real world as well. So there have been reports on data poisoning, so where really an adversary really tries to poison the raw data. Poison as in they try to inject statistical artifacts into your raw data, which will actually degrade the quality of your training process. Then obviously, when you transfer your raw data into your machine learning pipeline, you need to take care of data not leaking out. There have been cases where configuration files have been stolen, and as I said, these configuration files, sometimes they are called hyperparameters. This is really what your Coca-Cola recipe is, so this is really what you need. This is your intellectual property in most cases. We have seen, or there's actually a complete class of attacks which are so-called adversarial attacks. And these adversarial attacks actually try to steal your model. Well, sometimes not stealing by copying, not like copying a file, but stealing by probing your trained model. So the adversary is actually an algorithm itself, and it sends just an unlimited amount of requests to an already trained model. And by just observing the answers, it will try to extract the properties of the model. And there actually have been cases where not only the model itself was extracted, but even some of the raw data that was used for training purposes was extracted. And obviously the question here is, how can you protect yourself against such unlicensed and unauthorized querying of the model? More details are actually part of this article which I mentioned, so securing the machine learning lifecycle. So the two questions we really try to answer are, what do I need to consider for securing my machine learning pipeline, at which stage, and what are real, known real-world attacks. So we really try to actually not only look at these academic laboratory examples, but we really try to look at examples where we've got relatively, where we were really confident that these are attacks that can happen in the real world. So I highly recommend reading this, this article. Now we actually slowly move over to the demonstration part. Axel, or the demo Axel will show you. And we are going to focus on one specific part of the machine learning lifecycle, which is we already have a trained model, and that model has been deployed on some kind of server. And now we want to make sure that nobody can access the model in an unauthorized or unlicensed fashion. So that's basically what the demo is about. And how do we do it? Well, we implemented a small project from the medical domain, and that is a classical, it is a classification problem. And we used 3,500 X-ray pictures, actually X-ray pictures of tuberculosis patients. And we trained a model, and that model basically is a classifier. It will be given a new X-ray picture, and it will decide, is this tuberculosis or is it not tuberculosis? So it's actually a program for assisting doctors in their daily work. We already protect the baseline, so more or less at the, not network layer, but at the sort of application level. We ensured that the transfer of data from the medical device into the pipeline is secure by means of CodeMeter. And now Axel is going to show you how we can actually protect the trained model against any unauthorized or unlicensed access with the help of WIBU's technology. So I'm going to hand over to Axel here.
Thank you, Andreas, for this very insightful introduction here to machine learning. And now I have the chance to make the link between cryptography and the ML model, which Andreas talked about. But at first, I want to give you a little overview of our CodeMeter technology, because I think not all of you know the basics now. So let's start. CodeMeter consists in its basis on a license server. This is the CodeMeter exe. And a license server, as the name says, contains licenses. And we have three fashions of licenses. On the one hand, there's the CM dongle, our most secure license, because it's housed inside the secure hardware element. And inside the secure hardware element is a smart card chip, which is assumed not to be accessible for an attacker. So this is a secure enclave, let's say, and an attacker has no real possibility to get the insights from it. Then we have our CMAct license. This is also called a soft license, and this is stored on a PC as an encrypted data file. And the encryption is more or less derived from an hash which is bound to the specific endpoint. So you can bind it to your hard drive, to your network card, etc. You can specify it on your own what to bind. And at last, we have the CM Cloud container, and as the name suggests, this is stored in a WIBU-hosted cloud server, and you can access then the license via user credentials, which you can pass when you want to access it via our API. But let's talk again about the license server. This is the entry point in the whole CodeMeter license system, and it can run locally or also on a network PC. So you can then have multiple clients which access one license server and get access to the licenses. I talked a lot about licenses, but what exactly is a license? So for WIBU, a license is mainly a firm code and a product code. And firm codes are issued by WIBU-SYSTEMS for each customer. And the firm code is selected mainly by WIBU. But you as a customer, you want to create your own licenses for your products, and therefore you can choose the product code. So product code is defined by the vendor, and you have multiple options to mark the product code as a feature for your software, or you can bundle several product codes as module items inside the product code. So this is mainly also used when you want to transfer licenses easily, then you would use module items. But I don't want to dive in very deep because we have other webinars over this. The main point is you as a customer have the possibility to define your own product code in a range of 4 billion, because this is the maximum for a 32-bit number. So when you want to have a special number for your license, then you are free to use it. Each product item takes some space inside the container. So, and we wrote here up to 2,000 product items per CM container. And this is mainly for CM dongles, because there we have limited space, and we estimated the very basic product item can be up to 2,000 times inside a dongle. But when you have more data stored inside the product item, this can be also less. And each product item has different product item options where you can specify a unit counter, where you can handle usage-based licenses, or you can set an expiration time so that a license expires at a specific time point. It's up to you, and the possibilities are kinda endless. So we covered the basics over the CodeMeter licenses, but how do we actually protect software using CodeMeter? And this is the CodeMeter Protection Suite. And here you see a big matrix. And this is one of our selling point, that we offer nearly support for all platforms. And as you see, we have Windows, Mac OS, Linux. So these are the basics. We have also Android. And Linux is a very large platform. So we offer also additional targets for like Moozle or let's say ARM, HF, libc. This is all things you can buy additionally. You see it in the last row. Additional targets basically mean that you get support for these more exotic platforms. But here you see we can protect native applications, which are the first 3 columns. Then we have .NET applications, Python, JavaScript, and Java. And for all these types of CodeMeter Protection Suite modes, we have different flavors you can choose. So we have the automatic protection, where you simply specify your license and let the CodeMeter Protection Suite do all of its magic to employ a basic protection. Then we have our modular licensing, where you can choose which feature of your program has a separate license. We have the IP protection mode, code moving, and in this case, the most relevant for this webinar is the file encryption mode, which we will show you for Python. And here you see also the article number, which is relevant for this. But let's dive a little bit deeper into the modules of the AX Protector. So I already said a little bit about the basic protection. Here you can choose a license list 0 for your protection. A license list is a combination of several licenses you can choose for your product. And the encryption is more or less on the whole program. We see later that it's different for native applications and IL-based applications, but this is the most basic protection. So you will simply protect your program. Then we have the modular licensing, where you can choose more than one license list and classify separate features of your software for separate licenses. Then I talked a lot about CodeMeter, but we also offer a protection mode where you don't have any licensing involved. And this is the IP protection mode. Here you basically protect your application with a secretly stored key, and you don't need any CodeMeter installed on your system, so the application can run on its own. So as the name suggests, this is only to protect the intellectual property of your application, and no licensing is involved. The most strongest feature we offer here at WIBU is code moving. And this is basically a technique where you define an isolated piece of code, which is then executed in one of our secure execution environments. And these are CM dongle and CM cloud container, because we assume an attacker doesn't have any access to it on a CM Act license. This wouldn't be the case because it's stored on your machine. And then the code is moved during execute or when it's needed, so on demand, inside the container, and is then executed there, and the result is transferred back to your application, and you can use the result data for further processing. The last mode is the file encryption, and this is basically the protection of generic data which is not inside the program. And here in this webinar, we use it specifically for protecting the AI models. I talked already about the binary mode AX protector and IL mode AX protector. So AX protector at first, this is the internal product for the CodeMeter protection suite. And in the binary mode, we basically encrypt machine level code. So strict assembler code, which is compiled from C++ programs, Rust programs, Go programs, etc. And this is available for Windows, Mac, OS, Linux, and Android. And on the other hand, we have the IL mode AX protector, where we protect the higher level languages. As you know, .NET has CIL as a higher level language, and therefore the AX protector.NET can protect it. In Python, it's Python bytecode or Python source code. The AX protector JavaScript protects JavaScript code. And for AX protector Java, we protect the Java bytecode. Both AX protector modes operate a little bit differently. The binary AX protector, in its most basic case, encrypts the whole application en bloc. So you have a text segment in your binary program, and the AX protector encrypts it with a license. And then during runtime, the whole segment with all methods contained is decrypted at once. This implies that you have a good performance during runtime because there's no decryption call executed when it's initialized, let's say. So the complete decryption is done during startup. But you also can define manually individual methods which you want to decrypt on demand. But this is a manual process. So the automatic process is the encryption of the application in one blob. Compared to this, the IL mode AX protector encrypts all methods, each for its own. So you have single methods and single classes encrypted, and therefore during runtime, only the method which should be executed is decrypted, no other method. This is an increased security because an attacker doesn't have any knowledge about methods which aren't executed because they weren't decrypted. And the downside is, no lunch is free. We have a very small performance impact when we actually do the decryption. Because when you want to execute a method and it's not decrypted, we potentially have to do a license call to our secure CodeMeter license. And then we gather the keys and then we can decrypt. So this is a small performance impact, but we employed several techniques to combine methods in one license list so that they share a key. And when the key is decrypted once, then it's used again. And also the application scales on its own, that high-performant functions are cached internally and are not encrypted and decrypted each time they were executed. So to give you also a little bit overview of the protection, on the left hand, we have a compiled executable, and it contains code. and resources. It could be a native application, it could be a .NET application, it doesn't matter, it's always the same. You have methods in there and also some resources. The X protector encrypts the application using firm code and product code you specify. I mean, in case of IP protection, you only tell it that it uses the IP license. And then you have on the right side all the methods which are encrypted in the IL mode each, and also the resources are encrypted. You also see at the bottom that we have a little AX engine, and this is needed to actually do all the work during runtime to decrypt the methods. For native core-based X protectors, you also have an external component which does some licensing management stuff, but it's not relevant here. So now let's finally head to the demo where we want to see how a machine learning model is actually encrypted and protected by the X protector Python. So I prepared something. And we have here our Windows application, and I will first dive into the application, and it's the same as Matthias showed you before. Let's first go into the server file. So at the very top, we have our server which receives data from a client. In this case, it's an image. And we want to classify if there's a tuberculosis disease or not. And tuberculosis disease is predicted in our case if it's above 50%. So this is this branch. And on the other hand, if we are below 50%, we have no tuberculosis. So this is our server application which uses a trained model. This is in this case the trained model H5. We can also look into it. And we see some header which stands for the H5 model. And we also have some data here which parameterizes all the stuff needed for the network. So how is this application protected with X protector? In our encrypt batch, we have two calls. At first, we want to encrypt the server application itself, and we also want to encrypt the model. And these are two encryption steps. As I said before, the X protector needs some encryption specification. In this case, it's a YAML file. And we specify our license. In this case, it's 6.10.15 and type CodeMeter, so we really need a CodeMeter license. The license list is in this case 0, so it's basic protection, and it uses the CodeMeter license. As we want to support file encryption, we also need to set file encryption options to true for the application. If you wouldn't do that, the application wouldn't accept any encrypted files or wouldn't be able to process encrypted files. The output of the X protector is then put inside the protected folder, and we also want to specify what input files are used for the protection, and these are all inside the original scripts. For the trained model, we have our file YAML. And here the main difference is that we have our protection mode data. So this means we want to protect generic data and no script or executable code. The rest of the YAML is it's the same, except that I now pass 14 as a product code to distinguish between the server application and the trained model for license access. And also the input file is now the model instead of the Python code. So let's encrypt the application. I head over to the folder and then start our encryption. And here we see the X protector Python encrypts Python methods. And the second step we encrypt the trained model. So let's first look at the protected files. Now we see that the server PI looks a little bit different, because now we don't see our code anymore. We only see some methods with weird names and AX-engine load. And this is because the AX protector encrypts on method level the contents of each method and puts it into a secure data section. And the secure data section is contained inside an AX-engine file at the very bottom. So here in this data areas is your application stored secretly and bound to a license. We also look into the model to show you, this was the wrong editor because we want to compare the hex files. So I drag it into it, and now we see the start is different. Now we have a different header. In this case, it's a WIBU file header, and all data is not readable anymore, so it's encrypted. Okay, the application is now secured. Let's try to start the server. So I prepared a little script. And here we see it throws an error, but this is an intentional error because it says license not available. CodeMeter license 6.10.15 is needed. And if you remember, we specified the 6.10.15 in our YAML that it's the firm code and product code for our server script. So I want to link now a dongle with the license in my VM. And we also verify that we have the licenses in CodeMeter. So I open CodeMeter CC, click on the dongle, go to web admin. And here you see we have now a dongle with 13, 14, and 15. So it should work. I will clear the CodeMeter log that we see the expected license access. So now the server is starting. And now we see two calls. In the first row, we see that it's trying to access license 6.10.15, which is the license for the server script. And now it could be found because we have a dongle. And now we also see a second line here. It's 6.10.14, and this is the license for the trained model. So we actually see the model is now really requiring a license to be loaded. So now let's head over to our client, which performs tuberculosis predictions, or prediction requests, better to say. So this is simply a call in Python to the client, and we give over two images. At first, we give an image without tuberculosis, and at the second line, we have an image with tuberculosis. So we expect the server to output the first one is not tuberculosis, and the second one is one. So let's run it. And we see the server already does its predictions, and we see the first one is predicted to 99% no tuberculosis. And the second one for 68% a tuberculosis case. So this is really the result we expected. But I want to show you something different also, because now we see here 4 times 6.10.13 called. And as you remember, Andreas told you before that the communication channel between the client and the server is also secured by using WIBU technologies. And here we do an encrypt before we send data to the server, and a decrypt on the server to actually get the real data. And these are both times accesses on the client side and the server side to the license 6.10.13. And since we do 2 times the client, we get 4 calls. So I will demonstrate this also. We do a second time a tuberculosis call. So let me find this. So I expect now that 2 6.10.13 calls are appearing. So request was successful. We have our tuberculosis prediction, and now we see additional cores to 6 million, 10, 13. What you also see here is that the server application is initialized once. Also, the same applies to the model, because the application loads the model during its initialization. And then the model is stored inside a deeper layer of the ML framework, and it's not needed on file basis anymore. So we have only one license call for the application and one for the model at the beginning, and then no more. So this is something to keep in mind, and it may depend on your ML framework if a model is loaded more times than one. Okay, so this was all for the demo, and now I head back to the slides. So what did we see? We saw a client-server application which basically does image classification using a trained model. And in this case, we want to predict if a tuberculosis disease was detected from a scan or not. We used the expector Python using YAML files to encrypt, on the one hand, the server scripts, and on the other hand, the trained H5 model. And this is mainly to cover the case that no one is able to use the model without license and also doesn't see the model without license. And in the end, I showed you that the application only works with valid licenses, because we saw at first that there was a license error where 6 million 1015 wasn't found. And as soon as I plugged in the dongle, we saw that the application did the correct prediction of the scans. So this was all for the current possibilities for machine learning model protection using the expector Python. The file encryption mode also works in the upcoming version for expector JavaScript and expector.net. So if you have any ML frameworks there, you can also protect them using the expector. And also we protect different model types. So if you have another ML framework which doesn't use H5 files or something different, then you can also use the expector with file encryption for that data. And if it doesn't work, then simply head over to the WIBU-SYSTEMS support. We do our best then to try to support your model type. Thank you for your attention, and I hope you get some insight what's possible with WIBU, and you use in future our products to secure your machine level application. Thank you. So Andreas,
yeah, I saw one question. So the one question I saw is whether are we actually able to count the number of accesses can we actually control how many times somebody is making an API request to the trained model?
Yeah, as I showed you before, with the normal usage of the X protector, we only get to know the initial access to the license. And therefore, you can use the CodeMeter infrastructure to gather this data. To be able to count the usage, you would either need to protect an individual function inside your server or inside your ML application, which is then decrypted and each time it's used. So you would get a license access there, or you use a newly introduced API in the next version, which gives you the possibility to use the unit counter inside the license to make decrements there and give your customers an amount of licenses or amount of units which they can use, and then they need to purchase new amounts for this license. So these are currently the possibilities to employ a usage-based management of your machine level machine model.
Okay, that actually answers all the questions I had. So
Great. I got another question in the chat about the support of X-Protector native and machine level models. We actually have file encryption also for the X-Protector native, but this is currently not really on the same level as for our newly introduced X-Protectors, because they have specific techniques to support the new frameworks like PyTorch or TensorFlow. So the X-Protector native does it a little bit differently. There, we have to wait a little bit until we have our support also expanded there. Yeah, and there's also a third question, and this is about protecting code which is running on the GPU, and if you support it. And currently, we only protect code on the interface level of the ML frameworks and not below. So we are not in the driver level or anything. So we protect the interface in Python and JavaScript and .NET, which are used to communicate with the ML framework, but not something which is then derived from the model and executed on your GPU. This is something which needs to be researched, and it's something for the upcoming years, I would think. Yeah. All right, this was all which I saw now. And I think let's close this. And I wish you a very good day and see you next time for a WIBU webinar. Bye.
Bye-bye.